Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 2nd, 2025, about 2 days ago. The big hook is that this paper reports an average 44% improvement over DAPO on AIME 2025 by training large language models to generate and use reusable reasoning abstractions. The paper is titled RLAD, Training LLMs to Discover Abstractions for Solving Reasoning Problems. And as we will see later, the implications for model training are quite significant. In short, a two-player reinforcement learning setup learns an abstraction generator and a solution generator, which boosts generalization and even beats extra solution sampling at equal compute. Alright, the introduction set up why abstractions matter for breadth. Figure 1 illustrates the idea as a solution space graph, where nodes are intermediate steps leading to correct or incorrect answers. The left panel shows standard reasoning that traces a single chain, which risks missing other promising branches. The middle panel depicts generating textual abstractions by summarizing clusters of paths that share outcomes. The right panel shows using those abstractions to guide a shorter, more targeted route to the correct answer. So, Figure 1 set up why summarizing strategies could guide search. Table 1 reports pass at K and max at K coverage on ARC-AGI, and conditioning on abstractions consistently lifts both metrics. Pass at K rises from about 14 to 18 at K equals 1, and from roughly 25 to 33 at K equals 16, which is a sizable gain. Coverage similarly climbs, reaching about 43% at K equals 16, showing broader success across puzzles. Okay. Table 1 showed consistent gains with abstractions. Figure 2 shows that those gains depend on who writes the abstraction, how detailed it is, and how strong the solver is. The left panel indicates that only O4 Mini with long, detailed abstractions yields clear improvements, while short notes or weaker providers give little or negative change. The middle and right panels reveal that benefits grow with larger solution models, and long abstractions beat short or none across GSM 8K and GSM+. So, Figure 2 highlighted who should write abstractions, and how detailed they must be. Figure 3 presents the training loop, which links an abstraction generator to a solution generator through rewards. The left module proposes a textual abstraction for the query, and the middle module solves the problem while conditioning on that abstraction. The right side computes completion rewards for several solutions and averages them into an abstraction reward, so better guidance gets reinforced and weak guidance fades. While Figure 3 presented the training loop that ties abstraction rewards to solution quality. Table 2 reports accuracy across AIME 2025, DeepScale-R Hard, and AMC 2023, and the pattern is consistent. The RLAD row beats both the base and DAPO. With the best abstraction, accuracy reaches about 48% on AIME, 36% on DeepScale-R, and 92% on AMC. Even without abstractions, training with RLAD nudges accuracy upward. So while Table 2 showed headline accuracy gains, Figure 5 examines how to spend inference compute between abstractions and solutions. The figure plots AIME accuracy versus the abstraction-to-solution ratio, and performance climbs as more budget shifts to abstractions, especially at larger budgets. The left panel with K0 illustrates the trend even without discounting retries. The color scale on the right encodes total generations, which signals higher budgets where the abstraction advantage becomes strongest. Wrapping up, 2 takeaways stand out. Learning concise reasoning abstractions broadens exploration and reliably boosts accuracy, and the two-player reinforcement learning design cleanly rewards useful guidance rather than longer chains. The broader implication is practical. Allocate inference budget to diverse abstractions, which can beat brute force sampling and even transfer across models. Thanks for listening. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.